Alright, in today's video I'm going to show you how you can find the specific term of a binomial expansion. Now sometimes they'll just ask us for, say, the fifth term. Sometimes they'll ask us for a term that has a specific exponent for the variable or something like that. So there's all sorts of questions that could ask, but this will help us in all those situations. Now, there's actually two ways to do this. One is using the equation I'm going to give you now, and one is the long way, which is just to do actually the expansion, of course using Pascal's triangle, so that you can get all the terms and then pick out the term obviously that you want. Now from this point, let me talk you through a couple of things. The first thing is we're going to be using two variables fairly consistently. N represents the exponent of the binomial expansion. Now, that being the case, the exponent of the binomial expansion refers directly to the row of Pascal's triangle. Triangle starting with row 0. Alright? So when we look at Pascal's triangle, which I'll just put the first couple of rows here, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Okay, so if I wanted to choose something from this row right here, that would be row 0, 1, 2, 3. So n would be 3. All right, which makes sense because we talked about yesterday where if I had a plus b to the third power, that should end up giving me a to the cubed plus something times a squared b plus something times ab squared plus something times b cubed. And then we noticed with the 4 blanks, that would be this row right here. So 1, 3, 3, 1. Okay, and so again, that 3 for n refers to the 4th row, or row 3, starting with row 0. Okay, the other variable we're going to use quite often is r. Now r refers to the element. Okay, the element in the row, again, starting with element 0. Okay, and so for example, if I wanted to pick out this particular term right here, then I would say that n equals 0, 1, 2, 3, 4, 5. And then I would say that r equals 0, 1, 2, 3, 4. And so therefore it would be the 5th row starting at row 0 and the 4th element starting at element 0. Okay? Now the way that this is usually written is n over r like this. Okay? And so this specific term would be written 5, 4, which would be equal specifically to 5. All right, let's try one more, see if you can figure this one out. What if I said 4, 3? What would that be equal to? Okay, well, that would be row 4, 0, 1, 2, 3, 4. So I'm looking at this row right here. And then the 3rd element starting with element 0, so 0, 1, 2, 3. So that would be equal to 4. All right, so now that will be helpful in that we can write this then when we're writing out our Pascal's triangle. We don't necessarily have to write out the whole thing. For example, if I had a plus b to the 10th power, I don't necessarily want to have to go all the way to the 10th row of Pascal's triangle and write all that out. So what I would do is I would go a to the 10th plus a to the 9th b plus a to the 8th b squared plus a to the 7th b cubed, with the number in front each time, and so on and so forth. And then in front, I would put n 0, right? Because the exponent is 10 for all of these. because I'm referring to that specific row. Now element 0, element 1, element 2, element 3, and so on and so forth. And so you can actually write out the whole thing without knowing right away what these specific numbers are. Now, why is that important? Because then we can actually focus a little bit on the variables and the exponents if we need to do that, or whatever else we need to do. It's just a shorthand way of writing this out. Now your calculator can actually calculate this for you. If you push the math button, this is on your TI-84, if you push math and then you arrow over until you get to PRB, it's up at the top. Okay, and then there's an NCR. Okay, so if you go to the NCR, in front, you're going to type whatever the value of n is. So for example, if I wanted to do this one, I would put 5 in front, and then I would put 4 behind, and then when I push enter, then it should spit out the value of 5. Okay, now this is helpful because now we can get up to whatever row we want. We can do exponents of 75,000 and we can still get that specific element by using our calculator. Alright, so there's a couple of ways that we can use this. One is that we can now create kind of a general form for a specific term. Alright, so I'm going to use this right here that we were just working with. Alright, you'll notice that each term starts with this n over r, so some specific term. Now remember that the term, this is my first term, but it's the 0 element, and so the term will always be r plus 1, right? Because if the element is 0, that would be my first term in my binomial expansion. And so t of r plus 1 equals, and then it's nr, right, which refers to what we were doing before, where n is the exponent of the expansion and then r is the specific element that we're looking at. A to the, and then we need to have a power here, and then b needs to have a power as well. Now you'll notice that the exponent of b is always the same as our r, right? B here isn't there because it's an exponent of 0. B here has an exponent of 1. B here has an exponent of 2. B here has an exponent of 3, just like the r. So that's r. Now, how do we get the exponent of a? Well, it's n minus r. 10 minus 0 is 10. 10 minus 1 is 9. 10 minus 2 is 8. 10 minus 3 is 7. All right, so by doing this, we now have a general form of an equation that will help us to find any specific term of any expansion. Now, sometimes we'll be looking at this as a whole, and sometimes we'll look at pieces and we'll say, you know what, some of this isn't really important right now. All that really matters is the variable part of this. And other times we'll look at the constant. We'll say, you know what, the constants, the numbers are the only thing that matter here. And so essentially this will come in handy in many different ways, shapes, and forms. Keep in mind, this equation is not given to you on the IB exam. And so if you want to be able to use it, this is one of the few things that I say, you know what, this is probably a good idea to memorize. I haven't said that very often this year, but this is one of the times that I will say that. Now, you can always just write it out like I was doing here. And sometimes that's my personal preference because I always get nervous when I'm trying to memorize equations, and I worry that maybe I'm writing something down and all it takes is one wrong number. Whereas if I think through it and I write it out and reason through it, then I feel much more comfortable with my processing. So, and then sometimes it's just having another way to do it, a way to check yourself. All right, so I'm going to leave you with that. Go ahead and look at the other two videos in which I show situations where we actually do this. I'm going to try to work it in both ways where I both work it out logically and also where I work through the equation as well. All right?